Welcome to Section 8, Concurrency. In this section, we're going to learn concurrent constructs in Go. One of the most powerful things about Go is its concurrency APIs. And in this section, you will learn how to effectively use concurrency in Go. The topics we'll cover will be running multiple functions concurrently, passing data between concurrently running functions, waiting all concurrent functions to finish, and selecting the results of a concurrent functions as they are returned. Let's begin with running multiple functions concurrently. I have a piece of code here. Let's assume that these two are processing two different lists. Each list has items that are taken at least a second to finish. But for the practicing purposes, we're not going to have some actual code here, but just fmt println, and we're gonna sleep for a second within each iteration. So here, we first process the names, and here we process the ages. One thing you can notice is that they're not really dependent on each other. They're actually two different works. So let's go ahead and run this and see how that looks like on our console. Okay, as you see, they are coming along because each time they wait a second before they print out anything to the console. But if you look at it, you'll see that they're actually a sequential piece of code. Even though these four and these four do not depend on each other, we're still waiting for this for loop to finish before we can continue to the second for loop. We can make it more scalable and efficient by using concurrent patterns. So what I'm gonna do, I will use Go routines in Go. Go routines are different than threads, and they are more lightweight than threads. And unlike threads, they give the control back voluntarily instead of preemptively. And we're gonna talk about what that is exactly as we go along. So here, I'm going to convert this to independent piece of functionality into Go routines. So let's do this real quick. And I'm using the Go keyword here to make that. And as you see, I use anonymous function and right here, and I say to Go to run this function as a Go routine with the keyword Go. So I'm gonna do the same thing for ages as well here. So let's go ahead and run this and see how that looks like. As you see, instead of showing up sequentially, they're now showing up randomly. So one comes here and then the name. That means both of these loops are processed concurrently. Great. So let's go ahead and do something real quick here. I'm gonna remove this time.sleep here and see how that works now. Okay. So we don't see any result, anything on the console. It is because the main application is also run under a Go routine. And so that means we have like 3 Go routines, 2 of these, and the one is the whole application. And the problem, as I said before, is Go routines give control back to other Go routines voluntarily instead of preemptively. So that means when you use a time.sleep, the control will be given to other Go routines. And if I do that, our system will work properly. Great. But what happens if I use 1 second instead of 10 seconds? I'm going to run this now. So 1 second was not enough for other Go routines to finish their own work. And once the main Go routine is done processing, it shuts off the entire application and does not give enough time for other Go routines to complete. So there must be a better way of handling this situation. And therefore, we have another construct called channels. So for the sake of simplicity, I'm going to remove the second Go routine and we're going to use the channels now. So the way you define a channel is to use make function and say channel and the underlying type. That means I'm going to keep a string value in this channel. And instead of using fmt println here, what I'm gonna do is to send some data back to this channel. And I'm using this operator to do that. And here I'm just saying name. There are 2 types of channels. One is buffered and the other is unbuffered. When you use this type of channel, this only accepts one value at a time. So when you try to send another value, it actually effectively blocks this Go routine until this name channel is emptied. The way you empty is to read data from it. And what I'm gonna do is to say println and name channel. And this is how I do that. Of course, since there will be some data coming from name channel, I'm going to use range operator to constantly read data from it as it's filled. So what I'm going to do is this. Name channel. And I'm going to write the content to println. Okay, so I'm going to run this now. Okay, things are looking good. All right, so we are getting this exception. The reason of this exception is because when you're done with a channel, you need to close it. Otherwise, this for loop will keep waiting and waiting. But since your go routine here is pretty much done with that channel, this will go into a deadlock. And Go detects that, stops your application. So one way to close a channel is to use close. And I'm saying the channel. So when a channel is closed, the loop will terminate. So let's go ahead and run this. Great. So as you see, we didn't get any exception here. So everything looks fine. If you don't care about the result, if you want to use our first approach like so, then you can do this. We're going to send some data to channel, and it can be some dummy data. That's all right. I'm just going to do this. And here, I'm just going to discard the value. And the way you get the value from a channel is to use this operator at this location. So if you look at this, you send data to the name channel and you read it by using this. So let's go ahead and run this. Okay. So what we did is we are writing everything to the console, and once the loop is done, it sets the name channel. And here we wait until we get some data from name channel. Therefore, we don't terminate the application. Once we get some data from the name channel, we read it, and we don't really assign it to anything. So we just read it, empty the name channel, and that means the main Go routine can proceed the next line, and there is no code in the next line, and main function is exited. Therefore, our application is closed. That's how you can use channels and functions to do concurrent operations. Before I end this tutorial, I just want to reiterate one point about channels. If a channel is empty, and if we try to read an empty channel, it will block its Go routine. Once it is filled so that we can read something from it, we read the data and continue to the next line. The reason why the main Go routine could not be exited because we didn't send any value to it until this line. And this is much more effective than using a timer like we did in our previous example.